Hello, my name is Nakamet Paratapong and this is Scott Refrigeration Test Lab. I will introduce the equipment of this lab for you. This is fan, this is condenser, and this is evaporator. Inside there's air tube, there's a fan at one end, and at that end open to the open air. The middle of the air tube is the evaporator that will release the cool air and will blow by the fan to the outside. The center of the air tube is sensor that used to monitor the temperature and moisture, and we will read by to monitor on this. The left one is for the refrigerant and the right one is for air. That's all. Thank you.
Hello, my name is Kanita Suha, and I will introduce you how the system works. First, this one, it is the condenser, which changes the vapor to liquid. And the liquid will go on to the expansion valve, which it will reduce the pressure and make it to vapor. And after this, it will be cool and the air will blow out, which is cold air. And then it will go back to the compressor, which will increase the pressure. And then it will go back to the condenser, and the process can repeat again. Thank you.
From this is the result of our experiment. This one is the enthalpy of the refrigerant. This is the COP. This one is from the air. And this one is the humidity ratio.
Okay, so in order to start air conditioning, we have to set the compressor to make work, to put work in there. So after we get the work, we release the heat from the refrigerant by using the condenser. And to step 4, we conduct the heat from the surrounding to the refrigerant so that the surrounding will be cooler while the refrigerant will be hotter. That's how it will cooler, because the heat is sucked out. Okay, for COP, it stands for coefficient of performance, and it can be calculated by heat that is released and the work we put in. So we can see that work in it is the difference between this point is roughly about 20 kilojoule per kilogram, and for the Q out it's roughly about 200 or something. When we calculate the COP, it will be around 3 or 4 times